Okay, it says a particle's position at any time t in seconds is given by a function s of t equals tangent inverse ln x. So let's find a velocity function. So s prime t, vt is equal to s prime t, which is going to be equal to the tangent inverse formula, which is going to be 1 over 1 plus ln x to the power of 2, and then we're going to multiply this by 1 over x, right, because of chain rule. Okay, so we basically have 1 over x times 1 plus ln x to the power of 2. Alright, moving on to number 14. Okay, so for this problem it says find the equation of the line tangent to the velocity function at 0 pi over 4. So v of t is going to be 1 plus 1 over e to the 2x to the power of 2 times 2e to the 2x, right? So 2e to the 2x all over 1 plus e to the 2x to the power of 2. Okay, and then v prime 0 is going to be 2, right? 2 all over 1 plus 1 plus 1, which is 2 over 2 or 1, right? So our v prime 0 is going to be 1, and then y pi over 4 equals 2, 1 times x minus 0. So y equals 2x plus pi over 4 would be our answer. Okay, and then number 15. If g of x is the inverse of f of x, find g prime 5 is equal to f inverse of x. G prime is going to be something that we need to find. So according to the derivative of inverse equation, we're going to have 1 over f prime f inverse of x, right? So g prime 5 is going to be equal to 1 over f prime f inverse 5. Okay, so let's look at when the output of f is going to be equal to 5, and that's going to be when x is equal to 3, right? So that means we're going to be finding 1 over f prime 3, or 1 over 4 would be our answer. Okay, for number 16, our last question, since there is a function which is the inverse of h of x, we can kind of set that as g of x, which is equal to h inverse x, right? So in order to find a derivative of this, g prime x is going to be 1 over h of h inverse x, right? Okay, so this is basically the derivative function based on the formula. And then find the derivative when x is equal to 3, right? So when x is equal to 3, so when g of x, or g of 3, then h inverse of 3, right? So that means that we have to find when h of x outputs a 3, right? So when x second minus 8x plus 16 is equal to 3. And we have a couple of points, actually 2. So x minus 4 to the power of 2 is equal to 3. X minus 4 is equal to root plus or minus 3. X equals 4 plus or minus root 3. So this obviously makes sense, because if you were to graph this, then you would be getting like 4. Okay, and then you're trying to find when this is equal to 3, when any of the function values are equal to 3, and we have 2 points. And then our 2 points are likely going to be 4 minus root 3 and 4 plus root 3. So we have those 2 points, and then now it's time for us to put this into the h prime. Oops, I forgot prime here. Okay, so what is h prime? H prime is going to be 2x minus 8, right? So let's plug in 4 plus root 3 and a 4 minus root 3 into h prime. So we have 2 derivatives. One is when h prime of 4 plus root 3 is going to be 2 times 4 plus root 3 minus 8. Okay, so if I were to calculate that, I would be getting the answer of around 3.464. H prime 4 minus root 3 equals 4 minus root 3 minus 8. So negative 3.464. So these are actually positives and negatives. Yeah. And then we would be plugging this in, right? Because we just found this. So we would have to take the reciprocal, right? So reciprocal would be, or I'll have 2, so I'll just divide it in 2. So 1 over 3.464, so around 0.289, and then around negative 0.289 would be our answers. Okay, or when x is equal to 3, g of x, or the derivative of the inverse function of h of x would be around 0.282 plus or minus. Okay, that's it.